our last chapter, over the years, I've taught Math 9 a few times, and it's a hit and miss with students. Sometimes they find it easier, sometimes they find it harder. We'll see how it goes. It's a short chapter. There's only, usually it's like 4 or 5 days in a linear system, plus homework and stuff like that, 4 or 5 days worth of notes. I'll tell you right now, the first day and the last day are probably the harder concepts. The first day is probably the hardest one. So if you're doing well today and understanding it, this chapter probably wouldn't be too bad, right? There might be some other skills that creep up along the way that cause you some difficulties, but overall, if you can understand today's concept, this chapter should go well. So this chapter is on determining an equation of a line, okay? So you're given a pattern, and your job is to come up with an equation for that pattern. Okay? So at the grade 9 and grade 10, all the patterns follow a linear pattern, so like a line. When you get to grade 11, they start following like a curved path. Right? So right now, you're expected to come up with an equation of a line. Right? So let's look at the first example here. Right? We've got a hexagon. In the next series, in figure 2, we've added 2 hexagons. Can you see the pattern happening? Mm-hmm. What would the next image look like? Yes, Biman?
3 hexagons.
3 hexagons, right? And just to be a little bit more clear, it would be 3 hexagons with them sharing one side each, right?
Yeah.
So something like, yeah, that's me. The hard part. So that's my 2. The third one, you could add it up above, but I'm just going to probably add it below because it's just as the way the room is going here. 3. Okay.
The third hexagon, isn't it drawn wrong?
No.
Oh, no.
That's, I'm just adding the lines in a different color, just make it highlight what's been added. And what would the fourth figure look like? Yes, Mohad.
Before,
yeah.
hexagon. Yeah,
Hexagons.
Oh, hexagons.
Hex means 6-sided object, right? If you decide to take chemistry in the future, you'll learn that this is the shape of a benzene molecule, which is in a lot of your volatile organic compounds. Hmm? So the fourth one. Okay. So that's good that you can recognize a pattern and draw it. That's stage 1, right? Then stage 2 is to come up with a relationship to determine what is the pattern going on here. So the question here is to come up with the relationship for the number of sides compared to the figure number. Okay, so the figure number is here, and the number of sides, this is 1, 2, 3, 4, 5, 6. So the first diagram has 6 sides. Now, maybe I'll clarify this. We'll do outside sides, or maybe exterior. The lines in between don't count for this example, okay? Exterior side. So for figure 2, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? How many sides do figure 3 and 4 have?
Figure 3 has
Jacob?
Wouldn't it be 15?
14.
14, yeah.
18.
And 18, thank you. Okay. Right? So usually patterns are easier to detect sometimes just by visually looking at it, the first one, then putting a numeric sense makes it a little bit more difficult. Then the next stage where it becomes more harder is to determine a formula. Because looking at this, without drawing it, could somebody tell me what the fifth one, how many sides was it, Isaiah?
22.
Yeah. So, a couple of you guys already noticed. What did you guys notice?
4. We're at 4.
Each time it goes up by 4, right? Now, that plays a key role in determining how to create a formula, right? Because if I asked you, what's the 100th figure look like, or how many sides is a 100th figure, you don't want to draw 100 of them or keep on going plus 4, plus 4, plus 4. You want to be able to create a formula, right? So the way the formula system works, actually before we do that, describe the pattern. The figure, you guys said this, increases by 4 each time, right? Okay. So there's 2 steps in creating an equation, okay? First step is to figure out how much you're going up by in each case. And what we do is with that number, we multiply it to our figure. So we call it 4n. So we're going up by 4, and we multiply by our figure, all right? Then what we do is we go, this is a start of our formula. I want to test how well this formula works. So if we're using this formula, for our first figure, where n would equal 1, where n stands for the number of figures, it says that our object should have 4 sides, right? Which is incorrect, right? Our formula, we want our formula to say our object has 6 sides. Yes?
Shouldn't the formula then be 4n plus 2?
Yeah, that's exactly where I was getting to, right? That's the second step. Then you go, okay, we created half the formula. The second half of the formula is like, how much did we overshoot or undershoot by? Right now we got 4, it needed to be 6. So we actually need to add another 2 to make this work, right? We'll have to go 4n, maybe I'll do it off the side here. 4n plus 2, right? Right, let's test it out. Let's test it out with the third spot. If our formula is 4n plus 2, and you go 4 times 3 plus 2, so that's 12 plus 2, that equals 14. It works, right? You can try it with another one, right? Try it with the 5. 4n plus 2 equals to 4 times 5 plus 2, which is equal to 20 plus 2, which is equal to 22, right? It works, right? All right, so now, okay. Do we need to fill in these blanks? You guys understand that? All right. Okay, so the equation we came up with was sides is equal to 4n plus 2. Okay. So once we have a formula, we can use and apply that formula. So if we asked how many sides does the figure 13 have? Right? We use this formula. Sides is equal to 4n plus 2. Okay. What do we do with that 13, with this formula? Yes, Isaiah?
You do 4 times 13 plus 2.
Yeah. 4 times 13 plus 2. So we have 4 times 13 is, what, 62 plus 2. So it should be 64. Right? Did I do that right? No.
I think it would be
52. 52 plus 2 should be 54. So how many sides does it has? It has 54 sides. Now, good thing about it, there's only like 2 main questions that we can really ask you, or a couple main questions. We can ask you to come up with a formula, figure out the number of sides. The other one is, if I tell you how many sides there are, what figure is it? So once again, you're using the same formula. And David, what do we do with this formula?
I think we divide it.
All right? So it's saying 82 sides. So where do we put the 82? What do we replace in the formula with the 82? Yes, David.
You do 4 and plus 2 equals 82.
Yeah, 4 and so we're replacing the sides with 82. Okay?
And then you do the last chapter stuff.
Now's the last chapter stuff. Now the good thing is these equations are a lot easier than the stuff that we were doing last chapter. So we have to solve for n. So we need to get rid of the 4 and the 2 off that side.
Minus 2.
Which one do we go first?
Minus 2.
Minus 2. Yes. Minus 2, minus 2. All right? So we're left with 80 is equal to 4n. Right?
20.
Then we got to divide by that 4. Divide by 4, divide by 4. N is equal to 20. So the figure, which figure? It's figure 20. Not too bad, huh? So if you can follow those steps, some of the problems do get harder, but that's the general idea of this chapter, right? And we look at how do we graph these equations, right? And we look like how do you from the graph can you get the equation? But those are the steps we're sort of building up to. Let's do one more of these together, then I'll have you do one. What would the third and the fourth figure look like? So when you're trying to figure these out, you start off with the original one, and I'm going to just shade it in and see if I can tell the difference. Yes, Braden?
You add 2, so we have 7.
So you're going to have, so you add 2?
You add 1 on each.
Add 2, yeah. I'll add 1 on each
Yeah.
length, right? So you make the L a little bit bigger. So this one went 3 by 3. So this is the annoying part of this chapter, is actually drawing out these diagrams.
What if you're not good at drawing?
They're squares, man.
Yeah, I can't draw squares.
I'm not Mozart.
Yeah. I will not judge you on the quality of your squares,
Good.
right?
Because my square.
But I will judge you on if you have the wrong amount of squares, right? Like my drawing skills are,
Squares look more like circles.
right?
I'm gonna make a rectangle.
Yeah, I will not judge you if it's not a perfect square. Mine don't look like perfect squares either. So the next one, we do again the same thing, right? So we have a 4 by 4 this time, and we add 1 more there, 1 more there, right?
Now we flip the page.
Now we flip the page. I should have made this better. I should have made this all on one page. That's my fault. I'll do it better for my next quarter class. Okay, so yeah, so this is all same part of the same question. All right, we'll see how far we get. So now we want to come up with a relationship between this time not the sides, but the number of squares to the figure number. Okay, so the first figure
Hey.
3.
has 3. How many does the second figure have? How many squares?
5.
5.
7.
And fourth one has 9. Okay. So if you were to describe the pattern, what is it?
It's plus 2.
Right? The number of squares is increasing by 2, right? The number of squares is increasing by 2 each figure. Okay. So we're going up by 2. Yeah, 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. You're seeing that pattern. Okay? So now we need to come up with an equation. Yes, Mohad?
3n plus 2.
We're not quite there. Right? So our first step, you go how much you're going up by times by 2, right? So you're a step ahead, right? Then we plug it in. We go, well, for this figure, n is equal to 1. So 2 times 1 is 2. Okay? Now we compare. We go, hey, our formula gave us 2. It should have been 3. What do we need to add or subtract to make this formula work? Add 1.
Plus 1.
Right? So our formula should be 2n plus 1. Okay? Number of squares, or s is equal to 2n plus 1. So let's give it a try. Let's give it a try on the third one here. 2n plus 1. Our number is 3. We're going to add 1. So 2 times 3 is 6 plus 1 equals 7. And that's good. It worked, and it worked. Right? So just test it out with 1 or 2 points, because sometimes you can make a mistake. Right? So our equation, we're going to skip all this. We'll just go for our equation. Say squares, or maybe just say s instead of squares. S is equal to 2n plus 1. Okay? So now, we have the similar 2 questions. Using this formula, take a moment, I'll get you guys to do this. How many squares would the 15th figure have? Or F, which figure has 69 squares? See if you can figure those 2 out.
Nice.
Alright? And you zoom. Okay. So, how many squares are in the 15th figure? Oops. S is equal to 2n plus 1. Isaiah, I see your hand shot up there. What did you do?
I did, so 2 times 15 plus 1
Yeah.
equals 31.
Equals 31, yeah. You don't have to show me 2 times 15 is 30 and plus 1. You don't need to show me those steps. You show me the first line, second line, third line, that's fine, right? Next one over. Mohid.
Do.
Sorry, I'm going to do this over here. 2n, s is equal to 2n plus 1. So what did you use this formula with?
I did 69 equal 2n plus 1.
2n plus 1. Okay.
And I minus 1 on
Yeah.
both sides.
Yeah.
And then I divided by that number that I
So,
got by 2.
so you minus 1, where you got 68,
Yeah.
equal to 2n. Okay, I'm going to start writing. I'm going to start writing like this. Like, in the previous chapter, we did minus 1 underneath both things. At this stage, like, if you feel comfortable, you don't need to show me that, okay? You can just do this, right? Minus 1 implies that, right? Then you can go divide by 2, that's what you said, and you can go n is equal to
44.
34. And that's fine, right? Like, in general math, those are the main steps I want to see. I don't need to see the minus 1 and the divide by 2. That's nice for the last chapter, because you're learning how to divide it. And if you still need to do that, go for it. But those are the major steps I look for. If you can do those steps, great. That's all you need to show me, right? Okay, excellent. Okay, so number 3, I want you to do all by yourself. Complete figure 4 and 5, and then come up with a relationship for the number of triangles compared to the figure number. So I'll pause this and I'll just put up the answer in a moment. Yes, Hunter?
What do you do when you're done?
When you're done?
Yeah.
You wait patiently and, oh, gotta help the people at home, yeah. So, yeah, we came up with 2n minus 1. I'm gonna repeat that for you guys, but for the people at home, right? So do check it a couple of times, right? Because you can make a mistake on your counting, right? So if you make a mistake on your counting, if you check your calculation on a couple of data points, you'll realize that, hey, I made a mistake in my counting, and I need to change my formula or change my counting to make it all work. All right. So then the second part here on C is translating this in an English statement. These are the word problems that you guys come across, right? So this is basically you creating the word problem, right? So what's the pattern, David?
Every figure adds on. Oh, yeah. Every figure adds on 2 more triangles.
Yeah. So I use the word increase. So there's this math vocabulary. Add, increase, they all mean the same thing, right? So it's part of that translation, right? It's like, how do you describe what is happening here to somebody over the phone, right? Not a video chat, over a phone, you're just talking, right? So,
What if it's deaf?
Oh, then
Can you show the picture?
yeah.
That's my phone.
Yeah. All right. So, when you're creating equations, right, use appropriate values. I use t is equal to 2n minus 1. Right? T standing for number of triangles, right? So E and F. Yes, David.
2 times 71 minus 1.
Yeah. Yep. And F you're solving, which I've shown up here, right? You should have came up with 42, right?
I didn't do it like that.
You didn't get that far?
I got it, but I didn't get it like that.
Okay, that's fine.
83 divided by 2, which is 41.5. And I know we are minusing 1, so I did 42.
No, that doesn't follow math logic,
Guys
man.
making some new formulas.
No, that wouldn't work for you, buddy.
With this
It worked exactly.
It worked this time because you rounded, right? And you're only adding and subtracting 1. If that number was plus or minus like 5 or 6,
Yeah.
it wouldn't have worked, right?
Different is good though.
Yeah.
Differently in that.
Okay.
Chunky boy.
So it's often easier to determine a pattern once you have like a figure, some pictures to look at. But sometimes it's not given to you in that format. It's given to you in a sentence. So in the next question here, a number pattern starts with or at, let me say 1.5. And each number after that is 4 more than the number before. So if the first number is 1.5,
5.3.
what would the next number be?
3. Oh, no.
What would it be?
5.5.
5.5. It's 4 more. We need to increase this by plus 4. All right? Okay. What would the next number be?
9.5.
9.5. Adding 4 again.
13.5.
13.5. There we go.
5.
Nice.
21.5.
Okay.
25.5.
Okay. So now that we have the numbers for the both variables, the number and the value, we need to come up with the equation. Remember, there's 2 steps. First step, figure out how much you're increasing by, and that becomes your multiplier to your n. Okay? So we are increasing by 4, 4n. Then we test this out. We plug in one of the data values. So I'll stick in the first one here. So I'll move this up a little bit. So for figure 1 here, 4 times 1 equals 4. It should have equaled 1.5. So what do we need to add or subtract to make it equal 1.5? Yes, Jacob?
2.5. Let's subtract 2.5.
Subtract 2.5, right? So 4 minus 2.5 equals 1.5. So our formula should be minus 2.5. Okay? So if you're not sure, what you can do is grab your calculator. Oh, mine didn't work. Maybe I can go calculator this one. Just go 4. We got 4. You go minus the value it should have been, 1.5. What it is equal? The difference is 2.5. If you're not sure where the 2.5 came from, right? Okay. So then we write our equation. So what's the appropriate letter to represent value?
4n.
4n is one of them, minus 2.5. What should this equal? What letter should it equal? No.
Oh,
What we're trying to find here is value. So maybe use the letter V, right? Okay. So this was our first guess at it, right? And hopefully we did it right, but we check our formula with another one, right? Before we answer any of the questions. So we go, hey, we have 5 data points, pick one, right? Right? Which one do you want to compare it to?
5.
3? I heard 3 first. So comparing it for 3, the value is equal to 4 times 3 minus 2.5. So 4 times 3 is 12 minus 2.5. So 12 minus 2.5, 9.5. So yes, indeed, it worked because 9.5 and 9.5. That's what it should have been. All right. So our formula is right. So now with confidence, we can use that formula for solving the rest of the questions. We may make mistakes solving the questions, but at least we know our formula is right. Right? So, just like the questions before, use this formula to do C and D. So I'm going to pause it, have you calculate it. So this is just like the last chapter. Set up your formula, plug in the numbers. Right? See if you get the numbers correctly. Okay, so it looks like most of you guys got this. So I have a question to extend from this. I have it up on there so you can check your answer. If, say in question D, when you calculated it, and it came up not with 60, but it said 60.5, what would that mean?
They're wrong.
Why are they wrong?
Because they are.
You added like another decimal?
Yes, Jacob?
Well, first off, they didn't subtract the decimal, and then they would also be 1 set, or half a set higher.
No, okay, say we change the question. And say instead of saying it was 237.5 and it said which term has the value of 276, right? And you come up with a number. I don't know what the number is. Say the number that did the math right, and the math says the number is 63.5. What does that 63.5 tell you? Right, Hunter?
Wouldn't you be dividing a negative, or not a negative, a odd and even? I don't know.
No,
about that. I feel like
it's not about arithmetic, but more of the context of the question. Yes, Jacob.
Because there's a decimal in it, it means that is it something went wrong, like they forgot to subtract the decimal?
You're more on the right track. The issue is that it has a decimal in it, right? N is your figure number, right? Figure 1, 2, 3, 4, 5, 6. N can't be a decimal. So if somebody asks you what's the 280th value, like, and you come up with a decimal, you're like, well, there's no figure that's going to have that value. That doesn't exist, right?
He got the number wrong.
Right? So that's the only thing I want to highlight on it. So we will,
Why can't you do figure 1.5?
right?
Why can't you do
Because they're whole numbers. They're whole numbers, right?
So they can only do whole numbers?
In this particular context,
Oh, okay.
all right? Because they're going up by 1. Figure 1, figure 2, there's no such thing as figure 2.5, all right?